Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to electric vehicles and different components related to electric vehicles. In the previous tutorials, which we already have looked into some of the components like pre-charge circuit, control pilot, and proximity pilot. In this particular tutorial, we will have a look into the concept of boost converter and how boost converter is able to develop some voltage across its output. So let's start with a problem. There is a guy who wants to develop something. He has a problem. He has a motor which is of 24 volt. He has a battery of 9 volt. He has the issue that he cannot run the motor with the 9 volt battery because the motor needs a 24 volt input, otherwise it will not rotate. So to solve this problem, he has multiple methods, but he wants to solve the problem with a cost efficient method, which also will suit for a low power application. As you can see, we are dealing with low voltages like 9 volt or 24 volt. There could be one option that he can convert this there could be one option where he can convert this 9 volt to a AC 9 volt and use a transformer, step it up, reach to 24 volt, and then use an inverter to convert that AC output into a DC. That 24 volt DC that it generates, that can be used to run the motor, but that solution will not be cost efficient. Along with that, as we will be using transformers, it will increase the weight of the entire system. And as we are already looking into the application related to the automobile industry, so there always weight matters. So what could be the possible solution? The possible solution could be he can use a boost converter. So the boost converter, we will see now how it will convert this 9 volt to a 24 volt. So he got a solution that he can use a boost converter. So basically, to use a boost converter, he needs some components. The major component inside the boost converter is the inductor, which helps the build which helps to build this voltage up. So the basic objective that he wants to achieve is to convert from 9 volt to 24 volt. And this is the one objective that he wants to achieve. And this is how a boost converter also works. Makes a lower voltage of DC directly to a higher voltage of DC, like 9 volt over here, to make it 24 volt with the help of this boost converter. So any application that needs to step up the voltage from a lower voltage to a higher voltage needs a boost converter. So how you will basically achieve that, and what is the major component that helps to achieve this? So if you see the boost converter, you will always find a inductor that always be present in the circuit. So if you see here, the voltage of the voltage of an inductor, how it basically rises. So when you apply some current, the voltage of the inductor rises like the waveform that is shown here, and gradually it reaches some saturation, or after some time it becomes saturated and the voltage will not further rise. So coming to the overall circuit for the boost converter, so this is how a boost converter circuit looks like. Here we have 9 volt as our input. We have a inductor. We have a switch, which is basically a transistor or a IGBT. And we also have a capacitor. So the capacitor is to maintain a constant voltage across the load. So basically load could be anything, an inductive load or a resistive load. Usually we do have loads like inductive and resistive, but yeah, here we have taken an example for a resistive load. So the overall circuit looks like this. So but the main point is how this circuit basically works. So there could be two state for this particular circuit based on the switch status, the PWM status. So if you see over here, if you see gate, the gate receives the pulse width signal. We will also see how the pulse width signal looks like. But when the gate receives a positive pulse, then the switch gets on. So basically the IGBT gets on. Then we will have a different circuitry. And when the switch is getting off, then we will have a different circuitry or different state of the entire circuit. So let's see like when it gets turned on and when it get turns off, how the circuit looks like and what are the waveforms that we usually get as the output, or what happens to the voltage of the inductor and the capacitor. So if you see, the first state is the on state, and when the switch is on, everything will be closed in the switch, and you will have a circuit like this. So over here, you can see the 9-volt battery is there, which is directly connected to the inductor, and a current is flowing through the inductor. And in this case, the rate of change of current, like how the current is changing, that depends and that decides how the voltage should rise in the inductor. So the rate of change of the current that is happening in this inductor will decide like how much voltage we can build up in the inductor. So you can see the voltage we are able to build up with the help of this equation L di by dt. So this stage energy will be built up and it will be stored in the form of magnetic field in the inductor. So next is the switch off state. So when the switch is off, then this will be the resultant circuit. If you see, so here the capacitor is now connected and the capacitor voltage will also rise based on the current that is flowing inside the capacitor, and capacitor gradually gets charged. But in this case, as the capacitor is getting charged, the inductor also uh, loses its voltage because now the inductor also providing some current into the capacitor. But in this case, which you can consider is the capacitor voltage rises, and with that you will be getting a rise in the voltage, which is basically um, to the rated voltage of the capacitor. So by choosing a proper inductor and a capacitor, you can rise the voltage by first half storing the energy, and the second half is building up the voltage in the capacitor. So if you see the on and off part of the switch, then in that case, how the on and off part will be decided for the gate, because we want to give some pulse to there, right? So in this case, what basically is done there, you are able to see in the screen that there is a green color line, which is a constant line. And whenever this constant line is compared with the sine wave that you are able to see on the screen, right? The yellow one, when the green one is greater than the yellow one, then the PWM output will be 1. So in this case, whichever you are seeing in the red color is the PWM output, uh, and whenever the constant line is being compared with the sine wave, then in that case you are getting a square wave. And whenever you are getting the green one is higher than the yellow one, then in that case you are getting a positive output, and that is 1. So this pulse is varying between 0 to 1 based on this comparison. But it is not always the case that you need to get a constant square wave, but you can change the width of the square wave based on your variation in the input voltage. So here you can consider the triangular wave as the carrier wave, which is basically the wave that we will not change at all. This will be getting from some signal generator, but the constant we can change over time, and based on this constant, which is the reference voltage, you will get the square wave. So suppose if you want to change now the width of the square wave, then how it should behave. So this is the wave, the carrier wave, and this is the reference wave. And based on this, as you can see, the variation is happening, and we are getting different variations in the width of the pulse. So that is how the pulse width is being modulated, and we will be able to control the switch position, whether it is on and off. So based on that, you can control the switch. So this is the concept behind the pulse width modulation and how you will be able to control the switch on and off state. So as we already seen, right, we have two states. One is on and one is off. So the on and off can be controlled with the help of this modulation or the pulse width modulation. So whenever you do this, then gradually your voltage in the output will rise. So suppose you have the reference voltage or the DC voltage that you have of 9 volt, which is the blue line, and you are getting the output voltage as the yellow line. Okay. So in that you will be getting a rise in the voltage in the yellow line, which is the output, and it is gradually trying to build up, and it will reach to the required voltage that you want to maintain. But here you can see there is some variations in the voltage of the output yellow voltage. And here you can see the red one, you are getting some ripples. So basically ripples are variation in the output of the boost converter that you are able to see on the screen. So in the coming tutorials, we will also see like how the ripples are being reduced and how you can achieve the concept of reduced ripple by varying the quantity of or by varying the values of L and C, that we will see the entire calculation as well. So this is the boost converter that we will be going to implement in this coming tutorial, and there we will see how the changes are implemented based on the waveform that we seen over here. So this is the entire concept behind the boost converter. One part is storing the energy, another part is dissipating the energy inside the capacitor. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. Have a great day ahead. Take care. Happy learning MATLAB. Thank you.